graphing quadratic functions. So continued from yesterday, we're going to talk about a couple things. The first thing is factoring. So this is something that we've done already. You know how to factor quadratics, but I just wanted to quickly mention, what does factoring a quadratic actually tell you about the graph of the quadratic? Right? Why did we spend all this time on factoring and a key word, finding the zeros, right, with quadratic functions? You probably have noticed when we graph them, we don't do anything with the factoring anymore. It's like two separate things, right? First we learned to factor, now we're learning to graph, but they are connected. So I wanted to talk about how they're connected. Oops, wrong sheet. So let's take a look at something like this. This was on your homework last night. 2x squared plus 4x plus 1. Right, and we graphed that, and it looked like this. -1, -1 is our vertex. Over 1 up 2. And that's as far as I'm going to go. We did the rest of the graph for homework, but let's factor this and see what we get. Okay. First of all, we can't really factor using Graphing trick because 2 times 1 is 2, and I can't think of any factors of 2 that add up to 4. So what do we do? This is probably a review from last year. What do we do if we can't just factor it out like that? You guys remember? It was a really cool thing you learned, and you probably memorized it for when you can't find the factors. Starts like this: -b plus or minus square root of b squared minus 4ac over. Does this look familiar? Oh, maybe you didn't do this last year. Okay, cool. We're not going to go there today, then. So never mind that. I'll just pick one that you can factor. All right. Yeah. Sorry, I thought that you guys had learned that last year.
Yes.
Okay. Let's factor this one because we can factor this. So this was another one from your homework. And it looked something like this. Oops. Something like that. Our vertex is at 2, 1. We go over 1, down 1. All right, how would you factor this? Because now we do know how to factor this. And we've reviewed this year, so I know you know how to do this.
Wait, is it 2, 2?
You find factors of -3.
The first thing that we have to do, or the first thing that we taught you to do, yeah, is to factor out -1. So we would rewrite this as -1 times x squared minus 4x plus 3. Right? Can we get rid of the -1? No, it's still there. Right? If we got rid of it, this would be a totally different graph. It would face upwards instead of downwards. So now we just factor this. Right? We have -1, and then factors of 3 that add up to -4. How about x minus 3 and x minus 1? And then if I asked you to find the zeros would be x equals 3, x equals 1. What does this mean on our graph? If I factor this, what does that translate to on the graph? So I find the zeros. What does that translate to on the graph? What have I just found? Where is x3 and x1? Where is that on the graph? X is 1 right here. X is 3 right here. That's where what? That's where the lines go through the things. Yeah! Okay, what do we call that? If I were having you graph just a linear equation, right? And you graphed it like this, what would we call this dot and this dot?
The point.
We would, okay, let me give you another one. This is called what form? Slope intercept. Okay. What is this number? What does it represent on the graph?
Where you start.
The y-intercept. So in a linear equation, we know how to find our y-intercept, right? What did we just figure out how to find with a parabola?
Or x-intercept.
Yeah. Finding the zeros, factoring to find the zeros, means finding your x-intercepts. Okay? That's what you're doing. So this, all this stuff that we've been practicing, has a direct correlation on the graph, right, at these 2 points. Okay. I guess that our next topic will be that formula that I showed you. Because you can imagine, if you think back to the homework from last night, like the first example I gave you, a lot of graphs don't intercept perfectly at even numbers, right? Or at even integers, not even even, at integers, right? They intercept at some weird point, and it would be really hard to find that by factoring. So there is a formula, which I thought you guys had learned, but you haven't, that helps you find the intercepts if you can't factor. Okay? Would there ever be an equation that has no intercepts? No x-intercepts? Can anyone picture a parabola with no x-intercepts?
Yeah. It was sideways. No, because it'll always be.
Here's
Wait, if there's one below the x line and
yeah, if our vertex is below the x line
or above
and
the
x-axis and it goes down, would this parabola have any x-intercepts? No. What about this parabola? No. All right. Nada. Okay. So it's good to think about that because we've talked so much about factoring, and then we kind of abandon it when we go to graphing, but there is still a correlation, right? Factoring is finding your x-intercepts. It's just that that's often not very helpful for graphing parabolas. The way that we've learned, I think, is generally easier. Okay, there's one other thing I want to talk about, which is, what if you were to see something like this? Is that a quadratic? Certainly doesn't look like the quadratics we've seen so far, right?
Wait, it is because it would be y equals.
Yeah, it is. It is.
-2.
How can we translate this or transform this into something that looks like the quadratics we've seen? Yeah.
You can multiply out.
I can multiply this out. So I could have y equals 2 times x minus 2 times x minus 2. Let's do that over here. What am I going to use? What's the acronym for this? Expanding this? FOIL. First times first, that's x squared. Right? Outside is minus 2x. Inside is minus 2x. Last is plus 4. Plus 1. Now if I continue to expand this out, I have y equals, I'm going to do 2 steps at once because I think you guys can handle this. 2x squared. I'm going to combine these, that's minus 4x times 2 is minus 8x plus 8 plus 1, and then 8 plus 1 is just plus 9, right? So 2x squared minus 8x plus 9. This is equal to this. And this looks like the quadratics we've done. So there's going to be a couple like this on your homework. For now, you have a couple options for graphing them. One, you can just expand it out like this, as we just did, and then find the axis of symmetry. There's a second option. Okay? And the second option is actually probably a better option. You can use a t-chart. If you were going to use a t-chart to graph this, what would be a good choice for x in this t-chart? 0 would be an okay choice. 1 would be an okay choice.
2.
Yeah, why would 2 be an awesome choice?
Factor out 2 is big.
Look at this. If I made 2 my x, when I plug that in to find y, I have 2 times 2 minus 2 plus 1. All of this just becomes 0 because this is 2 times 0 squared. So this whole part drops out. If x is 2 here, this whole thing becomes 0, y equals 1. And guess what? That is your vertex. This is our vertex. Okay? So, if that's your vertex, 1, 2, 1, wait. Did I do that right? I think I did that right. Okay. 2, 1 is our vertex. Where do I go from there? Just looking at this, you can tell me if I go over 1, how many should I go up? But it may not seem obvious at first. If I go over 1, I have to go up this many. Because think about it, when I expanded this, this is still my coefficient for x squared. So if I go over 1, I go up 2. If I go over 1, I go up 2. If I go over 2, I would go up.
How many of you did not flip your paper over?
4 times 2, which is 8, right? I'm not going to draw that. Okay. So there's just a couple of problems like this. If you start with a t-chart, choose the number that makes sense for x, that makes this 0. When you finish that, when you get your y, you've just found your vertex. Okay? From there, use this. This number is a. That tells us how wide or narrow our parabola is. Or you can expand it like we did, use FOIL, and make it look like the ones that you're more familiar with. It's totally up to you. So you have 2 options for this.